Welcome YouTubers to another episode in my Grammar Hero series. In today's video, we're going to continue our discussion about triangles, which again is a topic that has a very high likelihood of appearing on the mathematics knowledge subtest of the Armed Services Vocational Aptitude Battery. In my last video, I talked about the triangle sum theorem, and instead of talking about how to find the perimeter and the area of common triangles in this video, I'm going to skip a little ahead and talk about right triangles insofar as that's a topic that comes up frequently on the ASVAB. So in light of that, let's go ahead and talk about the Pythagorean theorem. To start, we're going to talk about it in a very basic way. And then as we progress through this video, we'll do some simple examples together. And then at the end of this video, we're going to do some practice problems that are going to mirror closely what you'll see on the ASVAB. So all that said, let's get started. The Pythagorean theorem, as you can see here, describes the relationship between the lengths of the legs and the hypotenuse of a right triangle. And more specifically, it's given by the formula a squared plus b squared equals c squared. In case it's not clear, right triangles are any triangles in which there's a right angle. And in case you haven't seen this in a while, this symbol right here, which I'll highlight in red, indicates that that angle is a right angle. The hypotenuse of, and let me copy the Pythagorean theorem right here so we can see it as we discuss things. A squared plus b squared equals c squared. Our c always refers to the hypotenuse, and that's always going to be directly across from your right angle in a right triangle. A and b, on the other hand, refer to the legs of the triangle. What is the purpose or importance of the Pythagorean theorem? Well, the Pythagorean theorem lets you solve for one of these values if you know the other two values. So for example, if you know C and B, you can use the Pythagorean theorem to solve for A. And similarly, if you know A and B, you can solve for C. Again, that's all the Pythagorean theorem is. It's a formula that shows you the relationship between the two legs as well as the hypotenuse of a right triangle. And more specifically, it lets you solve for either the legs or the hypotenuse if you have at least two of those things. So all that said, let's go ahead and take a look at an example. Again, the Pythagorean theorem only applies to right triangles. I can't stress that enough. Don't try to use this on something that doesn't have a right angle in it. That's a triangle. And in this case, we're given this triangle. We know it's a right triangle given this symbol here. And in this case, we know what A is. A is 2. We know what C is. Again, C is always going to be across from the right angle, and C refers to the hypotenuse. And in this case, we don't know what B is. So we're going to use the Pythagorean theorem in order to find that. And I'm going to start by writing down the Pythagorean theorem. This is a good idea to do as you work on these problems. Again, the Pythagorean theorem says a squared plus b squared equals c squared, where a and b refer to the legs of the right triangle, and c refers to the hypotenuse of a right triangle. And now we just plug things in accordingly. Again, a is 2, so let's plug that in for a. That's 2 squared. B squared, or b, is what we're trying to solve for, so we're just going to leave that as b squared. And finally, we know c refers to 4, so we'll go ahead and write 4 in place of c there. Okay, so now we're just solving this equation using some basic algebra. The first thing, and remember, we're always working out these problems according to the rule, the order of operations, which is, please excuse my dear Aunt Sally. That is, you work out what's in parentheses first, then you do exponents, then you do multiplication and division from left to right, and then you do addition and subtraction from left to right. In this case, there are no parentheses, That said, there are exponents, squares in particular. So in light of that, we're going to have to take care of these exponents before we can move on. And so let's go ahead and do that. 2 squared is 4, as we should know. B squared, we can't really do anything with that at this point. And then 4 squared, we should all know, is 16. All right, so we took care of those exponents more or less. So let's go ahead and keep working on this one. Again, we want to get eventually b by itself, but to get b squared by itself, I'm going to subtract 4 from both sides as my next step. This is going to cross out, leaving me with b squared equals 16 minus 4, which is going to be 12. Okay, so we're close to solving for b at this point, as we can see. That said, we got this square hanging out here, and we just want b. So I'm going to do the opposite of squaring this. That is, I'm going to take the square root of this side. What I do to one side of the equation, I have to do to the other side of the equation to keep it balanced. So this is going to cross out, leaving me with just b. But that said, we can see b is equal to the square root of 12. And while that is the answer, on the ASVAB, you're going to have to write this in simplest form. So in case you forgot how to do this, let's do this off to the side. Again, 12 is the same as 4 times 3, so we can write those two factors in the radical. And then we can more specifically break those apart into their own radicals, namely radical 4 times radical 3. Square root of 4 is 2, so this becomes 2 times the square root of 3, and just like that, we took the square root of 12 and put it in its simplest form, notably 2 radical 3. Okay, so that would be the answer for this problem. Again, sometimes you're going to have to leave it in radical form like this. In other cases, you're going to get a nice whole even number. So you'll have that option as well. And you'll see that in this practice video, so don't worry about that. So let's move on to another example. Again, starting right now, we're going to do some very basic examples. So if you're following along at home, it's a good idea to try to work on these on your own. More specifically, I recommend that you pause the video, try to work out these 3 on your own scratch paper, and then play the video to see if you and I came up with the same answers. Again, on the ASVAB, you're not allowed to use a calculator or a reference sheet. And so let me stress this again. You're going to have to do all this work by hand. And by that same token, you're going to have to memorize the Pythagorean Theorem if you already don't have it memorized. So let's go ahead and take a look at this one. Again, in case it's not obvious, this is a right angle right there, which means 20 is our C. Again, it doesn't matter how we label the legs. I can call this one A, which would make this one B. And in this case, you can see we're trying to solve for A. So to start, not surprisingly, I'm going to write down the Pythagorean theorem. A squared plus B squared equals C squared. I'm going to fill in what I know already. I know I'm trying to solve for A squared, so I'm going to leave that as A squared plus B, which is 10. So that's going to be 10 squared. That is a bad 0 there, so let's fix it. Equals C squared. Again, C squared is going to be 20 squared. Again, according to the order of operations, we got to take care of these exponents. So let's go ahead and do that. Again, A squared is what we're trying to solve for, so there's nothing we can do at this point. Plus 10 squared. 10 squared is 100. Again, that's the same as 10 times 10. And similarly, 20 squared is 400. Now, if you complain that I did that in my head, I'm going to say this. On the ASVAB, you should know your squares from 1 squared, which is just 1, all the way through 20 squared, which is 400. You need to memorize those because as you'll see in this video, I'm not going to stop to do 20 times 20 by hand. Again, that's too time consuming. Again, memorize 1 squared through 20 squared. And again, you'll do a lot better on this test than doing the arithmetic, which is where a lot of people make a lot of small mistakes, including me, which is why I try to avoid doing arithmetic as much as possible. So with that said, let's keep working this one out. All right, so again, we've taken care of the squares, so we're good there. Let's go ahead and try to solve for a squared now. To do that, as my next step, I'm going to subtract 100 from both sides. This is going to cross out, leaving me with a squared equals 400 minus 100 is going to be 300. Again, we want to get just a in this case, not a squared. So that's going to prompt me to do the opposite of squaring, that is take the square root. This is going to cross out, but to keep this equation balanced, I'm going to have to take the square root of both sides. So this is going to leave me with a equals the square root of 300, which is a perfectly fine answer, but you won't see it as an answer choice on the ASVAB. Again, the ASVAB wants your answer in simplest terms, which the square root of 300 is not. So off to the side, let's think about what we're going to do with this to put it in simplest terms. Well, we can break this down to 300 to be square root of 100 times 3. Okay. And as I did in the previous example, we can break this down to be the square root of 100 times the square root of 3. I know the square root of 100 is 10, and then we can't simplify the square root of 3. So this becomes 10 times the square root of 3. And just like that, we found the length of A. All right, so on the ASVAB, you may be given just the 3 parts of a right triangle and be asked to solve for the missing part. So let's go ahead and do 2 examples of that. Again, in this case, we're going to have to draw our own triangle if it's helpful, or our own right triangle if it's helpful. And I'm going to indicate that this is a right triangle with that symbol. We're given A and B, which of course are the legs of the triangle. So I know this can be 12 and this can be 5. It really doesn't matter how you label the legs, as long as you get them on there. And then of course, this is the most important part. Always across from the right angle, you have your hypotenuse, or C. So with that done, let's go ahead and start plugging things into the Pythagorean theorem, which is a squared plus b squared equals c squared. Don't get intimidated by these big numbers. As you'll see in a few examples in a few minutes, big numbers usually aren't that difficult on the ASVAB, and they will give them to you to try to make you panic. All right, so we're told that b is 5 and a is 12. So let's plug those in accordingly. This is going to be 12 squared plus, I'm thinking ahead there, 5 squared equals c squared. All right, according to the order of operations, we got to deal with exponents next. So let's go ahead and work out these squares. 12 squared is 144 plus 5 squared, which is 25, equals c squared. All right. In case you can't do this one in your head, it's fine to work this off to the side. 144 plus 25. 4 plus 5 is 9. 4 plus 2 is 6. And 1 plus nothing is just 1. So this becomes 169 equals c squared. Now, in mathematics, it's customary to write the variable you're solving for on the left. So let's go ahead and just flip-flop these real quick. That is, let's let c squared equals 169 from left to right. And as we did above, we're trying to solve for just c, not c squared. So we're going to do the opposite of squaring, and that is to take the square root of both sides. This is going to cross out, leaving us with c equals square root of 169. Again, I said to memorize the squares from 1 to 20. You would know right away that this is going to be 13. Okay, so this one is 13. Again, as I mentioned, the solutions to these are either going to be radicals or whole numbers. In this case, it worked out nicely, and we got a nice even whole number there. So that one's done. Let's go ahead and do the next basic example. and then we'll get to the more challenging part of this video. Again, we know this is a right triangle. We're given 3 parts of it, notably one leg and its hypotenuse, and we got to find the length of the other leg. So let's go ahead and do a little diagram if it's helpful. And I'm going to indicate that that is my right angle. So I know right across from my right angle, that's going to be my C, which is 10 in this case. And I'm going to let this be 8 and this be B. Again, it doesn't matter how you label your legs. You can interchange those as much as you want. All right, so again, we're going to use the Pythagorean Theorem, which is a squared plus b squared equals c squared to solve this one. Again, we're told a is 8, so that's going to be 8 squared plus, again, b we don't know, so that's simply going to be b squared equals c squared, which is 10 squared. According to the order of operations, we now got to deal with these squares before we can move on. So 8 squared is going to be 64 plus b squared equals 10 squared, which is 100. Again, we're solving for b squared now, so we're going to subtract 64 from both sides. This is going to cross out, leaving you with b squared equals 100 minus 64. If you work with these radicals enough, or the Pythagorean theorem enough, you'll know that this is going to be 36. But that said, let's do it off to the side if we need to, just to get practice doing the arithmetic. 0 minus 4 we can't do, so we are going to have to borrow. Unfortunately, there's a 0 here, so we're going to have to come all the way over here and make that a 0 and make that a 10. Again, we're going to have to borrow one more time, so this is going to become 9, and now this is going to become 10. 10 minus 4 is 6. 9 minus 6 is 3. 0 minus nothing is 0, and so we can see that is 36. So let's take the square of both sides to get b by itself. This is going to cross out, leaving you with b equals the square root of 36, which is just 6. So in this case, b is 6. Okay, so with those basic examples out of the way, let's ramp the intensity up a little bit, and let's start looking at some ASVAB type questions. Again, if you're following along, it's a good idea to pause the video, try to work these out on your own, and then resume playing the video to see if you and I came up with the same answer in the same way. Let me say this, we know everything we need to solve these word problems, so it's just a matter of trying to use some critical thinking to get your way through these. That said, let's move on to this one. It says a 13-foot ladder is leaned up against a wall, and the foot of the ladder is 5 feet away from the base of the wall. How far up the wall does the ladder reach? Okay, so it's always helpful to draw diagrams in an effort to illustrate what's going on in the word problem. We know we have this wall here, and we have this ladder leaning up against it. Similarly, we know this ladder is 13 feet long, and we know that its foot, which is right here, is 5 feet away from the base of the wall. So we should notice right away that the ground is level with the base of the wall, so this is going to be a right angle, which would make 13 our hypotenuse, 5 one of our legs, and this value right here, one of the other legs. And the question says, how far up the wall does the ladder reach? So we'll go ahead and let that be our letter A. Okay, so we want to figure out what A is in this case. And as you can see, we're going to use the Pythagorean theorem since we have a right triangle here to do so. So let's go ahead and write that down. A squared plus b squared equals c squared. Let's plug things in accordingly. Again, we're trying to solve for a, so we'll leave that as a squared plus, again, I let 5 be b, so we'll plug that in accordingly. 5 squared equals c, in case it's not obvious, is always going to be across from the right angle, which means it's going to be 13 squared in this case. So let's keep solving. Again, according to the order of operations, we have to deal with exponents next. So this is going to be a squared plus 5 squared, which is 25, equals 13 squared, which is 169. Again, we're trying to solve for a squared, so we're trying to solve for a. So the next step is to get a squared by itself, which is going to prompt me to subtract 25 from both sides. This is going to cross out, leaving you with a squared equals 169 minus 25. In case we can't do that in our head, let's work it off to the side. As you do more and more of these practice problems, you'll just know what these values are going to be right away. But that said, let's work this one out. 9 minus 5 is 4. 6 minus 2 is 4. 1 minus nothing is just 1. So we can see a squared is going to be 144. Let's take the square root of both sides to get rid of this square here. We can see we're left with a equals the square root of 144, which is just 12. Okay, so in other words, this ladder reaches 12 feet up the wall. Okay, so that's that one. All right, let's move on to this next one. It says a soccer field is a rectangle 90 meters wide and 120 meters long. The coach asks players to run from one corner to the corner diagonally across the field. How far do the players run? Okay, so this, again, is a very typical type of question you'll see on the ASVAB. So again, we're told we're dealing with a rectangular soccer field. So that's going to look like this. And in addition to that, we're told that it is 90 meters wide. So that's going to be right here, and 120 meters long. So that's right here. Again, since this is a rectangle, we know this side is also 90 and this side's also going to be 120. We're told that the coach asked the players to run across the field diagonally like that. Okay? And in doing so, that splits this rectangle into two right triangles, as you can see. As you can tell, we're going to use the Pythagorean Theorem to solve this one. More specifically, we're trying to solve for the length of this diagonal. Again, this diagonal is directly across from this right angle, so we know that this is going to be our C, and 90 and 120 are going to be our legs of the right triangle. And again, if it's helpful, let's pull out one of these right triangles from this rectangle so I can show you what I'm talking about. Again, this is the diagonal there, C. This is the width of the soccer field, and this is the length. So as you can see, one slice, if we slice this soccer field in half, we do get two right triangles. So that said, let's go ahead and plug things into the Pythagorean Theorem now that we can see that we can use that to solve this one. Again, Pythagorean Theorem is a squared plus b squared equals c squared. In this case, we have a and b, and I'm going to let 90 be a, so that's going to be 90 squared plus 120 squared equals c squared. In this case, you can tell we're dealing with some big numbers. Again, 90 squared would be the same as 90 times 90. That's a lot of work. And similarly, 120 squared would be the same as 120 times 120. In this case, we're going to use a math principle to make this one a lot easier. More specifically, I'm going to cross out these corresponding zeros to do this work. Then I'll add this corresponding zeros back in at the end. So what that means is I'm going to take away this 0, and I'm going to take away this 0. And that technically means that I'm taking away a 0 from this c squared, which we don't know yet. So when I get done with this problem, I'll simply tack that 0 I took away back on. So let's go ahead and rewrite this without the zeros. Now this is 9 squared plus 12 squared equals c squared, albeit with that 0 that I have to tack back on to this c squared at the end. Okay, This looks much more manageable. So 9 squared we should know is 81. Similarly, we should know that 12 squared is 144 equals c squared. Let's go ahead and add these two together before we proceed. Again, that's 144 plus 81. 4 plus 1 is 5. 8 plus 4, 8. 9, 10, 11, 12. Carry your 1. 1 plus 1 is 2. So we can see that 81 plus 41 is 225. Of course, that equals c squared. Again, in math, it's customary to write the variable for which you're solving on the left. Right now, it's on the right. So let's go ahead and correct that. That's going to be c squared equals 225. Again, we're solving for c, not c squared. So that's going to prompt us to take the square root of both sides. And in doing so, that prompts this square to cross out, leaving us with c equals the square root of 225, which, if you memorized the squares from 1 to 20, you would know would be 15. And again, I took that 0 away here, so let me just add that 0 back in. So to answer this question, how far do the players run? It's going to be 150 meters. Okay. All right, so you might have to use that little trick I showed you there on the ASVAB. Again, no one likes dealing with big numbers. You can certainly do that, but I don't like using big numbers at all. So that was that one. Let's move on to the next one. This one says Sarah went to a level field to fly a kite. She let out all 100 feet of the string and tied it to a stake. Then she walked out onto the field until she was directly under the kite, which was 60 feet from the stake. How high was the kite from the ground? All right, so Sarah took a kite and staked it into the ground. Let's make this our little stake here. And as you know, kites kind of go off at an angle when the wind hits them. So in this case, and that should be a straight line, not a crooked line, but technology is not that great. Let's see if I can do it this way. All right, that's a straight line. So the kite goes off over here, and let's draw a little kite here. Got a little tail on it. And it, more specifically, she let out all the string, and it had 100 feet. So we know this is going to be 100 feet. And then it says she walked 60 feet to be directly under this thing. So she walked this way. Let me fix that. She walked 60 feet to be directly under the kite. And we want to know how high the kite is from the ground. In other words, we want to know what this distance is going to be. And as we can see, this makes a right triangle, which is great now because now we can use the Pythagorean theorem to solve this. Again, the angle, anything across the right angle is always going to be the hypotenuse. So we know 60 feet and this unknown value, which I'm going to call A, is going to be the leg. So let's go ahead and start by writing down the Pythagorean theorem. We've identified our legs in this right triangle as well as the hypotenuse. So let's plug those in accordingly. Again, we're trying to solve for A in this case, so that's just going to be A squared. B is the other leg of the right triangle, so that's going to be 60 squared equals C squared, which is going to be the hypotenuse, so that's going to be 100 squared. And as you can see, like in the last problem, we're starting to deal with some big numbers again. So let's use that trick I showed you. Let's cross out some corresponding zeros to make 66 and 100 just 10. Again, I'm going to write a 0 over here to remind myself that when I solve for A, I'm going to have to add that corresponding 0 back in. So again, this now looks like this. A squared plus 6 squared equals 10 squared. So now it's much easier to work with. And according to the order of operations, we're going to deal with these squares before we move on. So this is going to become A squared plus 6 squared, which is 36, equals 10 squared, which is 100. Again, we're trying to solve for a in this case, so we're going to subtract as our next step 36 from both sides. This is going to cross out, leaving us with a squared equals 100 minus 36. Let's work that out. 0 minus 6 we cannot do, so we have to borrow, but we can't borrow here because there's a 0. So we're going to have to borrow here. This is going to become 0, and then this is going to become 10. We're going to borrow one more time to make this 9 and this 10. 10 minus 6 is going to be 4. 9 minus 3 is going to be 6. 0 minus nothing is 0. So this becomes 64. And now we're going to solve for a. And to do that, we're going to have to get rid of this squared by taking the square root of both sides. This is going to leave us with a equals square root of 64, which is 8. And that's not the answer because, again, we have to add this 0 back in. So now we can see a is 80 feet. So to answer the question, the kite is 80 feet from the ground. And we set up a little drawing as well as use the Pythagorean Theorem, since this made a right triangle, to solve. Okay, so that was that one. All right, 2 more to go. And in these last 2, we're not going to cross out any corresponding zeros. We're just going to do the math. Again, I just wanted to show you that trick just in case it's helpful when you take the ASVAB. All right, this question says the diagonal of a rectangle is 13 inches. The width is 5 inches. What is the area of a rectangle? So even though we haven't talked about it yet, we should know that the area of a rectangle is simply going to be its length times its width. Okay? So let's go ahead and try to sketch what's going on here. Again, we're dealing with a rectangle here, and in case you haven't realized it yet, Pythagorean Theorem will be used a lot in regard to asking you questions about rectangles as well. We're told the diagonal of this rectangle, which is the distance from this corner to this corner, is 13 inches. And the width, which is over here, is 5 inches. We want to know what the area of this rectangle is, okay? So again, let's get rid of this diagonal and talk about how to find the area of that rectangle real quick. Again, this is the width of a rectangle. This is the length of a rectangle. And again, area equals length times width. So it's this side times this length. In this case, you can see that we have the width, okay? That said, we don't have the length of this rectangle. So that's something we have to solve for. We know that the corners in a rectangle are 90 degrees. So as we can see, by splitting this rectangle into 2 parts, it makes 2 right triangles, which will enable us to use the Pythagorean Theorem to find the length of the rectangle in this case. And if this is, and we should know again that the length across from the right angle is always going to be the hypotenuse, which means 5 inches is the leg, and the length we're trying to solve for is going to be one of the other legs, so I'm going to call that B. Again, let's use the Pythagorean Theorem to solve this one. Again, a squared plus b squared equals c squared. Let's plug things in accordingly. Since I let this be b, we know this is going to be our a, so this is going to be 5 squared plus b squared equals c squared, which is going to be 13 squared. And that's a pretty bad b there, so let's fix that while we can. Again, according to the order of operations, we have to take care of these squares before we move on. So 5 squared is going to be 25 plus b squared. There's nothing we can do with that right now. 13 squared, as we've seen previously, is 169. Again, we're trying to solve for b, which corresponds to the length of this rectangle, so we can use the area formula to find the area of this rectangle. So let's go ahead and subtract 25 from both sides. This is going to cross out, leaving us with b squared equals 169 minus 25. Let's work that out. and I think we've done this already, but let's still work it out. 9 minus 5 is 4. 6 minus 2 is 4. 1 minus nothing is just 1. So this says b squared equals 144. So let's take as our next step the square root of both sides to get rid of this square on this side, which will leave us with just b. Square root of 144, as we've seen already, is 12. And again, this b corresponds to this length of this rectangle. So now we have everything we need to solve for the area of this rectangle. So again, area equals length times width. Area equals, the length is, as we can see, 12 times the width, which is 5. 5 times 12, of course, is 60, and this is in inches. So the area of this rectangle is going to be 60 inches squared. And as you can see, we used the Pythagorean Theorem to solve for the length, which corresponded to b as the leg of a right triangle. So that's that one. Pretty common question you'll see on the ASVAB. All right, let's take a look at the final problem in this video. It says to get from his house to the library, Shane walked 3 miles east and then 6 miles north. How far is he from his starting point? Okay, so in case it's not clear, we're going to have to know our directions to make an accurate diagram. Again, this is a compass where this is north, south, east, and west. There's no shame in writing a compass on your scratch paper as you work these out. I know I did when I took the ASVAB. So let's go back to the problem and see what direction he's walking in. So let's say he's starting here. It says Shane walked 3 miles east. So that's this direction. He went 3 miles east and then 6 miles north, which is this direction. Okay, how far is he from the starting point? Which means we want to know this distance right here. And as we can see, this makes a nice right triangle where this is going to be our hypotenuse C, and these two values are going to be our legs. Again, he walked 3 miles east and 6 miles north. So in light of that, we have a right triangle, and we know we can use the Pythagorean Theorem to solve for the diagonal here, this length here, which is going to be a squared plus b squared equals c squared. Let's plug things in accordingly. Again, doesn't matter which of these you refer to as A or B. I'm going to call this one A. I'm going to let this one be B. A squared is going to be 3 squared plus B, which I let be 6. So that's going to be 6 squared equals C squared. 3 squared is 9, and that looks like an A. 9 plus 6 squared, which is 36, equals C squared. 9 plus 36, in case we can't do that in our head, let's go ahead and do it off to the side. 9 plus 6 is going to be 15, carry your 1. 3 plus 1 is 4, so 9 plus 6, in other words, is 45, and that equals C squared. All right, so in math, it's customary to write the variable for which you're solving on the left. So let's go ahead and do that. That's going to be C squared equals 45. Again, we're trying to solve for C, which is the hypotenuse, not C squared. So we're going to take the square root of both sides to get rid of this squared, which is going to give us C equals the square root of 45, which is not in simplest form. Let's go ahead and simplify that. Again, square root of 45 is the same as the square root of 9 times 5. The square root of, and then we can break this apart further as the square root of 9 times the square root of 5. Square root of 9 is going to be 3 times the square root of 5. And so this is going to be 3 square root 5 miles. Again, on the ASVAB, you're not going to have to know what that is as a decimal, but we solve this one accordingly. I don't know if you can tell, but by the time I got to this problem, I was a little fatigued. And again, I think one of the benefits to my channel is the fact that I give you more than one problem to practice these topics with. And if you go from start to finish in my videos, again, that's going to build up your stamina, which is going to help you prepare for the ASVAB in that way. That said, that's all I have for you in this video. I hope you found it helpful. If you like the content I'm putting out, please consider subscribing to my channel. I anticipate covering all the other topics that are going to appear on the Mathematics Knowledge Subtest. And then after I do that, I'm going to start covering the topics that are going to appear on the Arithmetic Reasoning Subtest. And once I do that, I'll keep creating some practice tests, and that should put us right around 150 videos. I plan on having all that done over the course of the next month or two. So all that said, you're more than welcome to leave some feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose. こんにちは。